Hey guys, so here's a problem that you might see in Newton this week when you're working through section 3.4. This particular problem asks us to find the acceleration. So I've given you a of t, find the acceleration at t equal 2 seconds. So let's take a look at what the original problem says here. The position of a car, this car might be traveling along a highway, is given by this function, s of t. Okay? T is measured in seconds, and S, this is an S right here, it's measured in meters. So you want to pay attention to what these units are, just so you'll know and be able to appropriately write your answer. In this particular problem, they wanted us to find the acceleration. So A of t is acceleration. And what we need to do is understand the relationship that exists between position, velocity, and acceleration. I'm just going to abbreviate this. If we know the position of an object, if we know the position function, we can find its velocity by taking the derivative. Okay, so this is calculus, and if we're not taking derivatives, we're not doing the problem correctly. Likewise, if I know the velocity and I want to find the acceleration, I can take the derivative. So we say, to get from position to velocity, take the derivative. To get from velocity to acceleration, take the derivative. Well, how would I go from position to acceleration? I just need to take two derivatives. Okay, so I'm abbreviating derivatives as d of x here. I'm going to start with my original function, s of t. I'm going to take the first derivative and then the second derivative. I like to do that like this. S of t equals 2t to the fourth minus 9t to the third minus 6t squared minus 8. And then if I take the derivative of that, I'm going to wind up with the velocity. So I would say that the velocity is equal to 8t to the third minus 27t to the second minus 12t. And then the derivative of 8 is just going to be 0. I can find an acceleration function if I take the derivative of the velocity. So we'll go in and we'll take the derivative of the velocity and we'll get a of t. 3 times 8 is 24, t to the second minus 54t minus 12. So what's important to note here is that we have an acceleration function, and I've been asked to find the acceleration when t is 2. So in this problem, we can break it down really into two steps. Find a of t, and then plug in 2. Okay. So had the problem said something like, find the acceleration at any given time, in other words, they don't give you a specific value, my answer would be this equation right here in green. But because they wanted us to find the acceleration when t is 2, I need to actually go in and plug in 2 for t. So we're going to find a of 2, which would be 24 times 2 squared minus 54 times 2 minus 12. So we'll have 24 times 4 minus 54 times 2 minus 12. You can work your calculator magic here. I believe 24 times 4 is 96 minus 108 minus 12. Finishing up here, so we're going to have negative, and I like to make sure that I have my values correct. So I'm going to take a minute. I'm going to check to make sure I do get my values right. Yeah, negative 12 minus 12. So these two values combine to give me negative 12. Negative 12 minus 12 is negative 24. So we would say the acceleration at t equals 2 is negative 24 meters per second squared. So those units are going to be really important as we go throughout this unit. All right, good luck with that, and please, as always, send me questions that you may have.